Hello everyone, we are going to see about reinforcement learning. So what is reinforcement learning? As we know that we have supervised learning, unsupervised learning and reinforcement learning. So in supervised learning we have the class labels, and unsupervised learning we don't have the class labels, and reinforcement, it is very important for learning right now. So what will happen in future, the agent will, what is the AI will do that. So let us go on in depth of the reinforcement learning. What is it meaning of reinforcement learning is reinforcement learning is a type of machine learning wherein the agents learn to make a decision by interacting with the environment to maximize the cumulative rewards. So here we will be seeing as trial and error. So what is the trial and error? Machine will learn first and it will check whether what kind of a data, and from that it will be identify what is the data is. It's like an human beings and the animals learn from the consequences of their actions. For an example, we are going to train a dog. What will happen? First, it will not train immediately. So you have to we have to give and treat and that like an reward to the dogs to train by ourselves. You without hold or say no when it does not something wrong. The over time the dog learns which behaviors leads to the traits. The reinforcement learning works the same way, but the software agents. So it's like it's work like in agents. So let us go for the in-depth of this concept in like an agents. What is the purpose of the agent is the learner and the decision makers, and we have the environments. Everything the agents interact with, state, the current situations or observations, actions, what the agent can do, reward, the immediate feedbacks and policies. So this is a policy which we have that the learning purpose of the data. The strategies the map the states to actions can be determinants or stochastics. The value functions estimates how a good state is in a long run. So these are the things we have. It is happening in the reinforcement learning. With the help of these components, the machine is learning by itself. So here the V of S is an accepted return starting from the state S and Q. So this is a Q which is used for the reinforcement learning. Expected return starting from state as taking action A. So what is the discount here is we are calling as alpha. So between 0 and 1 makes the futures rewards less important than the intermediate ones. So these are the components in reinforcement learning. So next one we have the explorations and exploitations dilemma. The one of the defining the challenges in reinforcement learning is balancing the explorations and exploitations. So what is exploitations? The agent choose the best known action based on the current knowledge to secure a reliable award. What is explorations? The agent tries a novel or abnormal actions to gather more information about the environments, potentially discovering much larger long-term rewards. So with the help of this both actions, these challenges, defining the challenges in reinforcement learning, which is used for understanding the data easier. If an agent exploits too early, it can be stuck in local optimum. For example, the mouse always taking the first small piece of the cheese it finds, never exploring the further down the kernel to find a giant cheese wheel. Too much explorations, slow learning. Too much explorations, stuck in suboptimal behaviors. The discounters for this here is the future rewards are worth less than the intermediate ones. The rewards of the plus 10, the next turn beats plus 10 in 100 turns. The alpha controls how much the agents values the futures. The value functions, instead of just reacting to the intermediate rewards, the agent estimates the long term, the values of begins in the state. So here how the good it is from here. So this is a overall review of an reinforcement learning. So you can see here that that agent is learning from the. So the agent going to learn here. So the agent going to learn the data, what kind of the data are and what is the trial and error. First we have to take an action in the environment. First we have to go for the environments. So here the data will be receive the state of S and S2 and rewards are there. So here it will be update the policy here. That means learning the data again. So it will be repeated until the goal is reached. Here with the help of the Markov decisions, okay, this is an important for the reinforcement learning, which has as S, A, P, or and alpha. So what is a S is the set of states, all possible situations, set of actions, all possible actions, transactions probabilities, that is the probabilities of moving to the state S dash from S by taking action A. The reward for this S and A and S dash intermediate the rewards received. So what is this? We have the discount, that is 0 less than alpha less than 1. The balance is the intermediate versus future rewards. So with the help of this Markov decision process, we are taking into an reinforcement learning into an actions. So what is the objective here is the finding the optimal policies, that is pi star, that is a looping. Okay, this is a looping that maximize the expected discount returns. So here the g of t is summation k equal to 0 to infinity. The alpha is k power k and rt. Okay, let us see in the next slides about this formula. Here one examples, the agents will move these directions if it is found any problems here, that is an, if we reach the goal we will get plus 10, if any obstacles we will get minus 1. So if it is empty per steps, then that is a minus 1 here. Finally the agents, this is a blue color we are calling as agents. So it is moving here, so that is a minus 1, that is a empty. So here there is an empty. If I am trying to move this part, it is shows that an obstacle, that is also minus 1. After moving the step by step, after that I will reach my goal state here. Okay, so that means I will get plus 10. It's like an world, okay, Ampus world problems. So where we reach that state. So already I have shared that video in our YouTube, so you can also watch. So next step, the common algorithms we have: value based, policy based, and actor critic. So with the help of these three algorithms, reinforcement learning is working very well. What is the real examples? So robotics, games, autonomous driving, recommendation systems, and finance. So this is the basics of reinforcement learning. So let us go on one more examples. We have that learning loop. So here that this is an agent. They are going to work on the environment here. So that is a state here. Okay. So from the states you can see the obstacle is there. When the state is agent is trying to start, agent task is action. So action is trying to move here. So this is the current state and it is moving towards this directions. So it is in minus 1 in this directions. We can see the successful path. So there is a path of this directions. I have to reach the state here. So you can see that rewards for this, and we can see the rewards if you are try to enter this path. Okay. So what is this? Here we don't have the path, so we don't have any data here like this we have, right? The agent task is action A. Action is move right. Then 3 environment evaluate the actions and provide the rewards here. So if I reach my destinations, I will get an plus 10. That is an goal of our state. Then here can see the learning policy updated. Okay, whenever I am moving to one place to another place, I have to update my learning policy. That is we are calling as pi, and move to the next state is s dash. So finally, I have to loop here, learning loop up to reach my final state. So which helps to learn the data by machine itself, right? That one we are calling as reinforcement learning. So what is a Markov decision tools? It is a mathematical models used in the reinforcement learning to describe how the agents learns by interacting with an environment. It based on the Markov property that which takes the next step. Next state depends only on the current state and actions, not on a past history. So Markov decision process which has S, A, P, R, and alpha. So what is the S is? Possible state, A is an possible actions, P is will be an S dash and S A. So here S dash is a next state and A is an action, S is an state. So likewise we have the R for the reward received after moving the one state to another state, and alpha discount factors that controls the importance of future rewards. If the alpha is 0, close to 0, the agents focus mainly on immediate rewards. If alpha is close to 1, the agent discovers the long-term rewards. The main goal of the agent is learn an optimal policy pi, which helps it choose the best actions in each state and maximize the total futures reward. So you can see the formulas for calculating this value of g of t. So here the equations represent the total discounts rewards collected over the time. So whenever I'm moving from one state to another state, I will have to check in rewards for collecting the rewards here, we have the equation like this. Next, there are different types of reinforcement learning we have discussed in the image. That is a value-based method. They learn how the good action states are. The example is Q learning, deep Q networks, Q learnings. We have this formula for the Q learning method. That is a value-based method. We have this formula to calculate. So here you can see the value-based is the focus learning the values on the states and the actions. And policy basis method is we are directly optimize the policies. The policy will be done with the help of reinforce and PPO. So very important policies here we have to check, right? PPO. We will discuss the base example of the PPO. So the proximal policy optimizations, actor and critics methods. We combine the value learnings plus policy learnings. So these are the example for this content. Next, we are going to see about the main approach in RL. We have the model free, model based, value based, and policy based, and actor and critic. So model free is learn directly from the experience, that is Q learning. Model based is build a model on the environments, learn from the values, directly optimize the policies, combine the policies plus values. So let us see that in detail about this. So what are the famous algorithm we have? Q learnings. So here deep Q learning, Q networks, that policy gradient and reinforce. PPO, so very important for the reinforcement learning is PPO. That is in very popular tables used in many real world applications like an OpenAI. Then soft actor critics, great for the continuous control with the entropy regulations. What is PPO? So we will go to check about the example of PPO is. The PPO is an reinforcement learning algorithms used to train AI systems to make a better decisions through the rewards and feedback. It helps the agents learn slowly and safely without making large mistakes during the training. So what is the main idea is agents learn by step. We have that learning image learnings to ride the bicycles. Sudden large turns may fall. Smooth turns, we have the better balance. So PPO works on the same way, small updates, stable learnings, and better performance. So here we can see the model of this equations. So E of AT approximately pi by theta. So this is with the help of these equations we are calling as this one we are calling as policy, the proximal policies optimization. So here ST is an state previous sequence of the tokens and the content prompt for so far. A of T is an actions, the current tokens being generated. Theta is in parameters, all the weights of inside your neural networks. So pi theta is in policy, the probability distributions. You have LLMs outputs and given content. How likely is each tokens? A of T is an advance, that is a reward we will be provided. Was token of response better or worse than expected? So with the help of these equations that PPO is working on, right? So reading this, we go to in depth of this equations in here. So delta of theta is an log of t. So what is this purpose of this? Which direction should nudge theta make this token more likely? This is a gradient of log probabilities of choosing a token. A of x is an scale that nudge by how good or bad that token was. If it is greater than 0, then push probabilities of up. If less than 0, then we have the push probabilities of down. Why log of the pi theta is working in this PPO? Taking of log turns multiplications into additions, which and gradients easier to compute. It also prevents the numerical underflow, which can multiple many small probabilities together across the long sequence. We have that LLM trainings. So this will be working on the LLM. The reward model scores a full response that's become an A of T. The policy gradients updates the LLM to produce more response like an good ones. This is essential how the CLAD and ChatGPT will be working on, or fine-tune the helpful and aligned. So with the help of this PPO, we are making that ChatGPT 4 and CLAD working perfectly. So let us see about the step by step, and we have the flow chart. The collection of transcodes, that is an agents interact with an environments, collect the states, actions and reward. Estimate the advantages, tells how much better these actions. So with the help of these equations, I can tell how much it is, and you go for the next state. Compute the probabilities ratios r of t is rt of theta is equal to pi by t. So with the help of this, we can compute the probability ratios. Clip updates prevents the extreme policy changes. This is in stabilized learnings, optimize the policies, use the gradient assess, and repeat the many epochs. The sample prompt from the data, so we are collecting the data here, and actors, policy generated response, reward model scores of response. So you can see that loop up to that we reach the final states. There is a critics estimate values advanced. A of t is equal to r minus v of t. So you can see that the probability ratios we are discussed in this point. So we can solve the problems in this computer probability ratios. So applying these clips to the limit policies updates and update the actors and critics weights. So likewise we will be repeating this status for the reinforcement learning. So this is a PPO, which is an familiar one, and it is used for like an very popular tables used in many real world applications. Okay, so this is the point. And what is the notable real world applications we are using in the robotics, autonomous drivings, gamings, LLMs alignments? This is the part where we are using this. Okay, reinforcement learning from the human feedback is used to fine tune the large language models, aligning their generates outputs with the human preference regarding the safety, accuracy, and utility. So recommendation systems also used in the reinforcement learning, finance, and healthcare. So these are the real world applications. What is the difference between the supervised learning and reinforcement learning? So we have the labeled data learned from the rewards, fixed data sets interactive with an environment, intermediate feedbacks, delayed feedbacks, correct answers provided, must discover the strategies. So what are the challenges we have? Sample efficiencies needs a huge amount of data interactions, credit assignments, the figuring out which actions caused by delayed rewards, explorations and exploitations when to try new things versus stick with a new known good actions. Stability, deep RL can be noticeable unstables. Partially observables, so we have this POMDP. Then rewards hacking, agent find the loophole. Okay, agent can find the loophole in the reward functions. So these are the major challenges in reinforcement learnings. So okay, and thanks for listening. Okay. So if you're having any doubts, you please comments, and thanks for the listening the video.